My name is Kumar Gaurav Gupta. I'm the CEO for Verdantis. We as a company has been in this space for almost 20 years. We started this journey with the data harmonization and now evolved completely into becoming a AI super agent for MRO. In the next 10-15 minutes I want to leave each of you with two key messages. One, we believe AI is going to be a force multiplier for MRO and MRO teams. And I'm going to share this by sharing a case study of one of the global mining companies headquartered in US, where we are working actively to address their MRO challenges. So this first slide is all about what MRO is and what is the difference between reliability and maintenance. So at our end, and I think that's the topic of the day today, at our end, as a company for MRO, maintenance, repair, and operations, as we feel, it starts with data, cleansing a data, standardizing a data, normalization data. Then moving to a next step where it is about finding the obsolescence, finding the alternate parts available. Then moving to a third step, which is about criticality, and then doing the inventory optimization or demand forecasting, and then the execution. So as a company, that is what we are active as a MRO lifecycle management. We still don't do a lot of work around asset health or the reliability or also the predictive maintenance. Okay. Now talking about our the customer where we have worked. It's one of the global mining companies which have mines across the world. They are headquartered in US. So there were three, the key problems what they were facing fundamentally. First, they had equipment downtime, but that downtime was prolonged for a lot of reasons. Okay, and it was prolonged. What it resulted was one, because it is getting long, so they felt that they don't have a spare parts, and then they end up saving or keeping a lot of spare parts, thereby locking their inventory cost and also the cost carrying cost. Second, this also resulted them doing the ad hoc or the maverick spend, buying ad hoc or asking different vendors, buying at a high price. And what happened was, typically, and you would probably agree, most of the companies don't even measure this maverick spend. But in their case, there's an incident happened that as part of the audit, that number came to more than 50 million for them. Okay, and that's where they said they need to do something. So this is what, when we started talking to them. So the challenge is, if you have to break it down at a more granular level, one was they were using ERP. They had a different demand forecasting system, but still they were facing a poor visibility of spare parts demand across different mines. So mines transfer, all those visibility was not there. Second, the criticality. As a company, they were doing criticality at an equipment level, and that too manual, and that too at a only for a few equipments. This was not cascading towards the spare parts. Okay, this resulted them assuming that most of the spare parts are critical, or not knowing what they don't know. Okay, all this resulted into, third, they have to keep a lot of spare parts, resulting in inaccurate reorder point, and also the static reorder point. They were not able to calculate or dynamically change the reorder points as they move forward. And the last part was, which resulted in a lot of money for them loss, was all this, if they have to address it, because the operations has to keep going on, they end up doing a lot of ad hoc demand planning, buying a lot of stuff, which resulted into a lot of spend, buyers issues, that the vendors were not cooperating, higher lead times, and inefficient operations. Now, how do we solve this problem? So as I said, in terms of the at a business level, at a broad level, what they were looking for was a fabric which can pass across all different silos of the organizations and give them a clear view around, or address their clear views around criticality, spare parts, demand forecasting, and then reordering. Okay? So the way we try to address this is, as I shared when I introduce ourselves, we as a company, we have a product called MRO 360. It's a native agentic AI platform. So three important things, and I'll share more details in terms of how we address step by step. But what it does is, one, because it's a native AI platform, a lot of the work can be done by AI agents. Okay. Second, in the demand forecasting world, as you may be aware, that there are a lot of different models, statistical models. Not that models were not existing earlier; they were and they are. But because of the emergence of AI and LLM, we are able to use those models, go to a granular level of data, do the analysis, and also leverage LLM to find the right analysis. And third, a biggest point which I at least believe is, typically in all of these solutions, the adoption is the biggest problem, because the users say that my core function is to do, a maintenance manager says my job is not to feed data, inventory guy says the system should give it all the information. With the agents doing a lot of work, okay, we believe, or we anticipate, that's the right word, that the user adoption will increase a lot. Now let's hear something about the product, how it works.
Welcome to this session on MRO 360, an enterprise software solution with embedded AI agents that solves some of the most challenging and I would say resource-intensive tasks in MRO inventory optimization. Production-intensive enterprises globally face tremendous losses due to mismanaged MRO inventories that can either inflate procurement and carrying costs or directly result in production downtime due to stockouts. To solve these challenges, enterprises are in dire need to understand the nature, consumption pattern, and criticality of their spare parts at a plant level with complete context of its uses and forecasted demand. So let's start directly with the demo. So first we'll show you the spare part search funnel. In multi-plant system, you would like to know how many spare parts there are in each plant, what are the like inventory cost of that material, how much material that can you directly use in the unrestricted, restricted way. So if I click on the view details here, you can see all the plant level details of a spare part, be it the min level, max level, safety stock, how many items are unrestricted, in restricted, everything is present here. Now we'll go back and move on to our second portion, that is spare part criticality. It is very important to understand that there can be one reliable global criticality score for a spare part, as it heavily depends on the context, that is the plant level or the equipment that the part is used for. If I just go down a little bit, you can see for each spare part, we are calculating spare part criticality, not only by one way, but three different ways. The first one is the current score that your company is allocating to your spare part. The second one is LLM analysis, or basically a baseline that the AI thinks should be the spare part criticality. And the third one is AI model, where we are passing on different parameters to the AI model to calculate the criticality. If I just click on this review button, you will see the various parameters we have considered for calculation of spare part criticality. Some of them I'll list are equipment criticality, function location impact, equipment role in the plant, and supply reliability. With this way, the AI is able to accurately calculate the criticality for the spare parts. The next module is demand forecasting. MRO 360 loads legacy parts consumption data along with several data points directly from the ERP system into the software to establish a trend line for future parts demand. If I browse a little bit down, you can see there are multiple different AI models that we are using to calculate the demand forecasting for each and every spare part. If I click on any particular spare part, you can see for the next considerable time period, for let's say 6 months, for 1 year, or if you want for 2 years, you get a pretty good view of the what's the actual demand is going to be for a spare part. If I browse down a little bit, you can see by month-wise categorization of total demand by spare part with a division between planned and unplanned for spare consumption. So in short, for the next month or the next 6 months, not only you would know the total demand, but also a division between how much demand is coming from my unplanned products versus planned products. So with this, I can say that criticality and demand forecasting go hand in hand, and it is very important for your plan. Thanks for watching.
So thank you. I think the idea was to showcase how we were able to address, just a small snapshot of how the product works, and how we were able to address the customer requirement. Now, coming of the approach one, so how we started with this journey was, the first and the foremost, we took the data from them, okay, with the clear, uh, anticipated, the outcome that was around, maverick spend, criticality, and also the inventory piece. Okay, so we first said that we cleanse the data, we industry, we ensure that it is as per the industry. We leveraged our auto enrich AI. It's an agent to enrich or get the completeness information from the OEMs and all other relevant sources. We also leverage the manuals and documentation of the nameplates they may have to ensure the data is complete. Okay, once we have the data complete, the next step was finding the reduplication, also trying to do the obsolescence, that there are a lot of parts or spare parts which could be obsolete. How do we address that? How do we ensure that the latest information is available? The next part was also finding what could be the alternate spare parts. Once we have done and managed and have a good, I'll say, the golden record in terms of the information and the data, the next step was moving towards the criticality. Now, if you see on the screen, it just and in our the product manager explained in our demo or the video how the criticality is calculated. So the way we have envisaged criticality is, this is the old versus the novel approach, and this is our view. There are three fronts. One, we believe that it has to be, with the it has to be with the human feedback, and that's where we said first capture the AI, the way people do their criticality in the SMEs do in the respective organizations, which could be ABC analysis or VED analysis, whichever way, based on whatever framework they have used. The second was then leveraging LLM to find out that in this kind of industry, this kind of equipment, in this kind of a region, this kind of a mine, this product or this spare parts, what could be the criticality. This helps us to get to know the industry view or the industry benchmark. Okay. The third was, then we have come up with some 15 or 14, 15 parameters. The customers can choose. In this case, they selected few of them, and we were able to capture those information from the data they had from the ERP, and the agents was able to calculate that data and come up with the criticality. And then you have these three criticality approaches, and you can find the variance. This helps us in two elements. One, when we started this journey, they were not doing criticality at the spare parts. It was done at the equipment level only for a few or a very limited view. Second, I would say our criticality, whatever the output was, I would not say it's 100% correct. It would be in the range of 60 to 80%, but it's better than not doing something. And over a period of time, this number will increase as we gather more data or more clean data. That's the case. The next chapter after criticality was the demand forecasting, because that was an important requirement. I think there are two important elements I want to share, and also one output which or maybe a stark finding there. One, we use the same statistical model like LSTM and Profit and all, okay, which has been there for long years. But because we are leveraging agents, AI agents, we were able to gather and analyze a lot of data, which earlier is very cumbersome and it is very difficult a lot of times. Okay. Second, whatever the output from the statistical data was, we'll or the models, we'll take it and feed it to the LLM. And that's where we get a hybrid approach in terms of what could be the respective demand forecasting, taking care of the seasonality factors also for that respective spare parts. Third, a very important part, a lot of these can be calculated again and again instead of doing 6 months or 8 months, till we reach to a stage where we have a good view or maybe a right view or a optimum level in terms of the forecast accuracy, which is not possible, which become a more trial and error exercise in case of a manual work. Okay. The last part, as more of a I'll just give one of the findings which got. So as a company, they said they want to see the forecast level based on PM1, PM2, PM3. That is more of a planned maintenance versus a corrective maintenance. And few of the months they found out that the corrective maintenance, the inventory or the forecasted level was much higher. Okay, and that was one of the reasons which resulted in them, because think like this: a bearing and an excavator versus bearing and a pump, which where it is more critical, and if something goes out, you don't know, and it is corrective maintenance, you are spending, you believe that you're keeping five more bearings, additional bearings or other some other spare part for excavator. That also results in the ecosystem cost, which is around the people. You have to get it down at the in the mine, all that information, because everything is not available, there are remote locations. All that resulted in a huge cost which they were able to manage once they have this kind of a view and they can proactively track this. Okay, the last part which is also very important in this case is they had a lot of material planners or demand planners which can, once they open their dashboard, they can see this is how my products are, this is how it should be in terms of the inventory stock in stock out, this should also be inventory in hand. It also takes care of the work orders. It also takes care of the lead times. So again, it is more proactive rather than ad hoc doing of calling, thereby helping them address the maverick spend. I would not say that they have made it zero, but it has substantially improved because it will take time for in terms of both the adoption and the accuracy. Now, these are the key findings and the results from our side. As I said, we are in a hypercare mode. So these are the anticipated results. Out of the parameters, we believe in terms of the critical spares, the improvement should be 70%, primarily because now they know what are the critical spares and they are not keeping everything. Second, because they know critical spares, the average inventory value should also go down because they know what to focus on, what not. Okay. This should also result in maintenance related downtime, primarily coming from the inventory, because now they know what is the critical spares. They can stock it. Hence, the total downtime or unwanted downtime can be reduced. The forecast accuracy, we believe that should be up by 26 points, and the savings we are assuming should be in the range of 6 to 8%. That's the anticipated numbers we've been calculating. This brings to me the last slide from our side. I think I just want to leave with you two messages here. One, I think I also believe that, and I started with the AI journey, and I'm just concluding on the fact AI cannot do everything, but what we learned in this process was a lot of things AI can do, which was earlier not possible. So it is how you view AI as an enabler in the MRO operations. And the second, I think that's a topic of the day or our session is this is also an example where they found, or even we were able to unearth that how do you move or move the MRO from a tactical way to more of a strategic lever. Thank you with this. Thanks a lot. Giving back to you.